Okay, thank you very much, Sasha. Hi, everyone. So, I'm Meni Rosenfeld. I'm from the Israeli Bitcoin Association, and I'm very happy to be here to start off the Bitcoin and blockchain track in this IoT conference. And I'll start with a short introduction, tell you a bit what Bitcoin is. So, Bitcoin is a new kind of money. It's the world's first decentralized digital currency. And throughout this lecture, we will try to figure out what exactly this means, starting with some basic dictionary definitions, and moving on to deeper stuff about what it means for IoT and in general. So Bitcoin is a currency, right? So I'm not going to focus much in this lecture on the economic aspects, more on the technology, but the currency basically is a tool that helps people trade. People create things, sell them, get some currency, and then they use it to buy the things that they want. So this was phrased very nicely by Homer Simpson, who said, money can be exchanged for goods and services. So this is the basic concept of what currency is. Now, currency needs to have some features in order to be a good currency, and everything which has all these properties can be a good currency, and we believe that Bitcoin, through the technology that we will talk about, has all of these requirements, which is why we think Bitcoin can be a very good currency. Now, Bitcoin is digital. Owning Bitcoins is not having in your hand some kind of physical object. It's access to some digital information. Whoever has this information is the owner of the Bitcoins. We use Bitcoin with computers and the internet, and it's all based on cryptography, which is a mathematical subject that deals with how to secure and verify digital information. Now, Bitcoin is decentralized. There is no company Bitcoin Ltd. There is no single controller or issuer that runs the currency and decides what goes on it. Instead, we have an open protocol and free software, and we have a peer-to-peer network of computers of people all over the world that run this free software, and together this currency works. And Bitcoin is the first. So we've had over history a lot of physical currencies that people used, like gold and other things. We have for each government, for each country, they issue their own currency. There are many centralized digital coins that we use with the internet and computers, but they have a specific company that controls them. But in order to have all of the features that Bitcoin does, it needs to be both decentralized and digital. And it didn't exist up until recently, simply because people didn't know how technically to have such a thing, a decentralized digital currency, until sometime in 2008, a person with the pseudonym Satoshi Nakamoto invented this way, and we will talk a bit about what it really means later. So before we start talking more about how Bitcoin works and what is good about it, I want to give some sort of analogy to help people understand what it actually means to use Bitcoin. How does the system look like for an end user? So I like to give an analogy of Bitcoin as some sort of vault, like a room full of safety deposit boxes that you have in a bank. So we have here these safes. Now, of course, these safes are digital, right? They're not actually made of metal. They are digital information. This information doesn't sit in a centralized server somewhere, but it sits on a cloud, right? On a network of computers that each of them has this information, and together they run the system. Now, if we look at one of these safes, then we can see several things about it. So first, every one of these safes has an address, right? This is how a Bitcoin address looks like. When I have the address of such a safe, I can find it in this large virtual vault and look at it. When I look at the safe, then I see it looks something like that. It's transparent. So once I found it, I can see exactly how many coins are there. It has this slit at the top, so you can put money in, right? If I have someone's Bitcoin address, I can send him as much Bitcoins as I want, as many as I have, of course, I don't need anything special to put coins in someone's safe. But the safe is locked. If I want to open it and spend the coins inside, I need a key. And this key is also digital information. It looks like this, like a long string of characters. Of course, a user doesn't need to know all this text. The software deals with it for him. But only the person who has the key can access the coins. So because of this, it's important not to lose your key and not to have someone else steal it, because once someone has your key, he can steal all your coins. And this is an example of how the actual usage looks like. So this is an example from an Android application called Mycelium. We have a few screens that display the balance, how many bitcoins are inside this wallet that lives in my phone. And I can send and receive, see the history of transactions, and so on. And just like this, we have also software for the computer and so on. And one last thing that we need to know about the Bitcoin system is its inflation schedule. So for every currency in the world, no matter its type, it needs to enter circulation some way. So if it's a physical currency, then it enters circulation when it's actually mined from the earth. And if it's a centralized currency, then the issuer decides how much to print and when. This is what we have with government currencies. But with Bitcoin, because it's decentralized and digital, we don't have these things. So instead, the Bitcoin protocol, the set of rules that decides how Bitcoin actually functions, defines how the coins enter circulation. So the rules say that there will never be more than 21 million Bitcoins, and they are generated in this gradual process in a rate that diminishes over time until it converges to 21 million. Now, every Bitcoin can actually be split into 100 million units, because you can work with 8 decimal places when working with Bitcoin's amount. So we don't need to fear that it's not enough 21 million coins, because we can divide it as much as we want. And later on, I will talk a bit more about how exactly they are generated and by who. OK, so now I hope we have a general idea of what Bitcoin is. I want to talk a bit about why it's good, why do we need it. So Bitcoin is just like the money we know, only better. And this manifests in a few advantages that it has over the systems that we know. So first, and the most important, is a mostly philosophical principle that with Bitcoin, we don't need a third party. So with the financial systems that we know, we need to depend first on a government to print the money, and then we need a bank to put the money in, and then we need the credit card companies, so we'll be able to pay it easily. And these are all entities that we depend on. We can't have our normal lives without all of these entities controlling the money. And this gives them a lot of power. And power is something that can be abused. And with Bitcoin, we don't have that. We have this open system that is run collaboratively by participants everywhere. And I, as a user, I don't need to trust anyone to use it. I can just create a wallet with this software on a computer or an application. And this gives me much more freedom and much more empowerment. And from this follow all the other things. So with Bitcoin, it's much easier to send or receive money. Because in the traditional system, if I want to send money, I always go through some intermediate. And I need to depend on him to tell me what I can or can't do. And it charges fees. And I need to go through all this bureaucracy. With Bitcoin, with just a few clicks of the mouse, I can send money to anyone, anywhere in the world, and I can do it easily and with almost no fees, and it arrives more or less instantly. So this is especially useful in the context of the Internet of Things, because The vision we have is that there will be many devices connected to the internet of all sorts, and they need to interact with each other in various ways. And one of these possible ways is financial transactions. Like they have a device that wants to put up an order to someone, like, I don't know, my refrigerator wants to put an order with the supermarket to order food, so it needs a financial transaction. Or if it's like a network device that needs to pay for content or for the actual internet access. So these are all things that will be needed. So just like money is a very important tool for the economy of humans, it's also a very important tool for the economy of devices connected to the internet and running autonomously. So it's very important for them to be able to do this without needing to rely on someone, without hassle, without fees, without delays. So I think that because of all of its advantages, Bitcoin can provide a very good service to all these devices. And we'll say a bit more later about other things that are useful here. So moving on with the list of advantages that Bitcoin has. So there is no single point of failure. There is no single thing or entity or whatever that if it fails, the whole currency stops working, because its operation is based on a network with tens of thousands of computers. So if some of them go down, it still runs based on the rest. And Bitcoin is also much more secure than what we know, because it's based on cryptography and the digital signatures on a network that synchronizes everything with a very powerful computational network. So it's very secure. Now, there are a few more economic things like the limited supply and the lack of chargebacks. Bitcoin is international. It's a single currency that can be used everywhere in the world, so we can use it for international purchases or in foreign countries. And also, it's pseudonymous. So this means that transactions in the Bitcoin network aren't identified with the real names of people, but with some sort of aliases like a cryptographic pseudonym. So when I send a transaction in the Bitcoin network, then what the Bitcoin knows is that address A sent to address B. So this is very good for privacy. And it's also important, again, in the context of IoT, because when we have these devices that handle their own transactional activity, then they don't have an identity in the same way that banks know for people. And of course, to create, for example, if each device wanted to open a bank account for itself, of course, it will be very much trouble. But here, each device can just create a pseudonym for itself, its own cryptographic identity, and pay based on it. And this way, all of these devices can interact with very little friction. We, of course, also have the open ledger of all the Bitcoin transactions that take place. So this is good both for knowing that everything is going on correctly, and also for several advanced applications that use this open ledger to store information about things other than just currency. And additionally, this technology allows you to use the money in much more sophisticated ways. So for example, one of the very important features is multi-signature transactions. I can have, instead of a normal Bitcoin address, which is controlled by one key, so this is like the normal usage that I have keys on my phone, and they can receive money to this address, to this safety deposit box that is controlled by my phone. But I can also have an address that is controlled by several keys simultaneously. So for example, if we have 3 people, we can create a joint account that money can be moved out of it by any 2 of the 3 participants. So it's similar to what we can have with banks, with accounts with multiple signature rights, But here we don't need a bank for this. We can do it independently ourselves with our own technology, with our own tools. And this has several applications. So for example, we have an Israeli company that unfortunately couldn't make it to present their product today. It's called Bitrated, which is a market for arbitration in transactions. If I want to buy something, but I don't trust the seller, then I can find an arbiter through this platform. And with the multi-signature transaction, we can make it so that neither party on its own can steal or lose the money. So this also has interesting applications for devices that want to do transactions easily without friction and without the chance of fraud from the other party. So this is the kind of applications that can be really useful. Now, despite all of Bitcoin's advantages, we still have a few challenges if we want to use it. It's still not very widely used. The legal status is not very clear. The software infrastructure still needs to be developed. And also the business environment needs more time to mature. OK, now I'll speak very briefly about the technology and how Bitcoin actually works. So the system actually has three major components. One is the definition for a data structure that defines who owns Bitcoins at any given moment and how they are transferred from one person to another. The second component is a peer-to-peer network of computers that verify all these transactions, broadcast them, and store them for later reference. And the third component is a system for computational proof of work, which is called mining, which has two purposes. One is synchronizing all the Bitcoin transactions, and the other is determining how the coins are initially issued. Now I'll go a bit deeper to each of these things. So first, we have this network of computers. Any computer in the world can run free open source software and become a node in the Bitcoin network. Together, they handle it. Each node transmits to the other nodes on the network the information about all the transactions that he knows. And everyone verifies that it's all correct. And everyone also keeps a record of all the transactions. And they organize it in a specific data structure called the blockchain. And you'll probably hear this word a few more times today, because the blockchain is really the innovation in Bitcoin. It's the technology that allows actually to make everything run. So the basic idea with the blockchain is that we take all the Bitcoin transactions and organize them into units called blocks. And each block contains a reference to the previous block. So together they form a chain. And people need to invest computational work in order to create these blocks. This prevents attackers from trying to take the system out of this synchronization because the blocks are ordered in this way. Now, this is an example for how a transaction looks like. Bitcoin transaction represents movement of coins from one party to another. So each transaction has some inputs that say where the money came from, and the outputs that say where the money goes to. And the transaction needs to be digitally signed by the owners of each of the inputs in order to be valid. Right? So only if I have the key for specific coins, I can authorize their use in a transaction to be sent to someone else. OK, now I'll go a bit deeper into mining, which is the innovation in Bitcoin, right? With transactions, they're very important, but they're not the new thing about Bitcoin. Mining is what's new in the blockchain. And like I said, it has two purposes. One is the initial distribution of the coins. So like I said, with any currency which is either physical or centralized, it's not a problem how to say who gets the money. But with the coin that is digital and decentralized, we have this problem, right? We want these coins to be created, but we need to decide who gets them. And we can think of several ways how to do it, but none of them really works. And the way that was found that is fair and measurable and pure and there's low overhead is proof of work. So people all over the world run a specific computation. Doesn't really matter what this computation is. It just needs to be something measurable that people can prove that they've done this computation. And then the coins are distributed in proportion to how much each person has done. So this is in one way arbitrary, but it still allows to settle the problem of how to create it. And in that, it won't really matter how the coins are really issued. The other reason that mining exists is to synchronize transactions. Now, every digital currency in general has a problem called double spending, which is using the fact that digital information can be easily copied to try to duplicate a coin that you have. So every currency needs to handle this. Of course, with a physical currency, it's not a problem because it's just a physical thing that you can't duplicate. But digital information you can duplicate. And if it's a centralized coin, then it's easy, right? You have a server that decides what goes where. But if we want to do it in a decentralized way, it's a bit harder. And the first solution that anyone came up with for this problem is the blockchain and mining invented by Satoshi Nakamoto. The basic idea is that each participant in the network votes on which order of transactions he thinks is correct. And this vote is done in the computational way. And the weight that each person gets in the vote is proportional to his computational power. And as long as most of the network is honest, then together they manage to keep everything in sync. Now, mining is really doing some specific calculation called SHA-256. And there are several kinds of hardware that we can use to do it. In the beginning, people used the normal CPUs of computers to do it. But now we have companies manufacturing application-specific integrated circuits that know only how to do mining, but can do it much better than any other device. And to conclude this part of the talk, actually we have several types of wallets. If someone wants to use Bitcoin, needs to create a wallet and use it. There are several types. We have full node software. We have paper wallets. We have lightweight wallets. We have mobile applications. So each has its own advantages and disadvantages. So everyone needs to decide what to use. Now I'll move on to the next part of this talk. If up until now I talked in general about the theory of Bitcoin, what it is, then I want to spend some time talking about what is the actual status of the Bitcoin project. Now we're in the middle of 2015, so what's going on now? So I'm going to talk about several aspects, and I'll begin with the technology. So the basic technological part of the Bitcoin network is the reference software called Bitcoin Core. Every computer that runs this software becomes a node in the Bitcoin network, a computer that participates in the verification of all transactions. So we have a group of core developers all around the world that work on it and release new versions. And in each new version, several features are improved. One of the most important things people work about with these new versions of the core software is its scalability and performance. And it's even more important than the security of the coins. So it sounds maybe a bit weird that security is not the most important. But the thing is that if the network doesn't perform well enough and the network crumbles under all the load, then nobody will be able to use their coins. So it doesn't matter how secure they are. So we need to make sure that the network actually works and performs. Now, someone that just wants to install a Bitcoin wallet on his computer has several other wallets he can use, which also differ from each other in their features. We have applications for mobile devices, for Android, for iPhone, so on. So we can take every smartphone that we have and install this application, and this phone becomes a Bitcoin wallet that can receive and send Bitcoins. Now, there are also some hardware wallets that give new ways to handle Bitcoins in a way that is both easy and secure. These are physical devices that are designed for one purpose, to be a Bitcoin wallet. We have a few of them. One of them is EliptiBox, which is an Israeli company, and they will also present here later today. Now, I mentioned that Bitcoin has mining, and these days people manufacture chips that are specific to do the computation of mining. We have several companies doing that. There's a big Israeli company, Tech, that manufactures these devices. And also something which is rather new, a company called 21, which is actually very interesting in our context here of IoT. It's a company that for a while people knew that it raised nice sums of money. It raised $100 million, but for a long time nobody had any idea what they're actually doing. Lately they released what they're doing, and they're working on mining chips that are to be integrated into other devices. So for example, I could have a phone, and inside the CPU of this phone, there is a core that does mining. And they hope that this way the phone can generate its own money and use it, and not just phones. And the other device can start mining on itself and use it for any interaction. And this is very important because it allows any device to generate its own money that it needs when it connects to other devices, and without needing anyone else, and without anyone needing to put money into it. So I don't know if their plans will work, but if so, they could be very interesting. Now, they say that imitation is the sincere form of flattery. So judging by that, Bitcoin receives a lot of flattery. So if we said that Bitcoin is the first decentralized digital currency, after it came a few others that use similar technology, but each one is a digital coin that is just not Bitcoin. Sometimes it's very similar, sometimes it's different, but we have a few hundreds of those. Now, Bitcoin is not just a currency. The same technology also allows us to create decentralized digital representations of many different things. So we have here some examples for projects that use Bitcoin's blockchain technology for things which are not just currency or not just its own native currency. So maybe one of the most obvious use cases is for companies that want to issue stock, and they want this stock to be traded just as easily as Bitcoins can be used and handled. So instead of going to these big exchanges, which you need lots of money just to be listed there, then anyone can issue digital tokens that are based on the Bitcoin network, but represent this company's stock. And then they can issue it, and they can be traded without third parties. Like if I have some Bitcoins, and Sasha has some coins that actually represent shares in some company, then we can trade between us without needing any intermediary. And this is just the first application. You can have all sorts of financial instruments and smart contracts. You can have smart physical property. You can have a car that can only be ignited with a key which is attached to a specific digital token. So I can actually sell my car by giving out this token with the same ease that I could send Bitcoins. And we have also ways to use the blockchain to store information, because the whole innovation of the blockchain is to keep everything synchronized without needing a centralized party. Then we can use it to put information in and prove that this exists. So for example, if I wanted to prove that a document existed in at some given point in time, then I can create a summary of this document and put it on the blockchain, and there it will be in a permanent record with computations that prove that it actually existed there. And there's also one of the most innovative projects here is Ethereum that allows you to create contracts based on scripts which are actually living entities which can define all sorts of interactions. And it's all based on tokens that are digital and that are decentralized, that don't need any specific party. So of course, all of these can have many applications for the kind of interactions the devices in the Internet of Things make use of. And of course, there's also a lot of academic research about these kinds of things, all of the different ways to use the technology and improve it. And we should also have later today a talk by one of the researchers which is active in the Bitcoin area. So next I'm going to talk a bit about the state of Bitcoin among merchants, people who have businesses and shops that want to accept Bitcoin. So first, some numbers. These are all estimates, but we have about 3 million Bitcoin transactions per month, total of $1 billion transferred per month. We have around the world about 200,000 businesses that accept Bitcoin. In Israel, about 200. And so far, about 10 million Bitcoin wallets have been created. So it probably means there are maybe about 1 million people around the world that use Bitcoin. Now, among all these companies that accept Bitcoin, we also have several large and known companies like Microsoft and Dell, many others. We have some more companies that deal more with the Internet things. All these companies don't necessarily accept Bitcoin themselves. They get help from companies specializing in merchant services. They handle all the process. So we have here several companies that were founded specifically to give services in the Bitcoin world. But we also have traditional payment services providers that have existed for a while that have started integration with Bitcoin. And now every merchant that already uses the services of one of these companies can choose to accept Bitcoin as well. And in addition to all the businesses that accept Bitcoin payments, we have also a large number of organizations that accept Bitcoin donations. Now, a few words about Bitcoin as an investment. So first, again, some numbers. The worth of all the Bitcoins in the world right now is $3.4 billion. That's more or less the monthly amount that it's traded in exchanges around the world in trade between Bitcoin and traditional currencies. Here we can see a graph of the price of Bitcoin, the exchange rate. It started at almost zero, and then we went up with a few oscillations. We have here a few exchanges around the world that allow trading Bitcoins for other currencies. Some which are specific to Bitcoin, some are a bit older that have integrated Bitcoin into themselves. People wanting to buy Bitcoins have several options. There are some companies dealing with international transfers, and there are EFTs, ETFs. And also there are some ATM machines, devices where you can put in bills of some government currency and receive Bitcoins. I hope that while we are here, we managed to bring one of these devices into the hall outside. So if anyone wants to experiment, you could use that. It's just a machine that trades shekels for Bitcoins. We also have devices that do the reverse. And in addition to all the ways that you can invest in Bitcoin itself as a currency, there's also been a lot of investments in startup companies that work in the Bitcoin space, all the technology companies, all the services companies. So many of the things I mentioned earlier, startup companies that have raised nice sums of money. And basically any VC that respects itself also has some investments in the Bitcoin sphere. Now, what gives Bitcoin its strength is the community of people that believe in it, promote it, work on it. And just like the IoT community that we have here that managed to organize this conference and has all these meetups, and Bitcoin also has a good community. So worldwide, the biggest hub for the Bitcoin community is the Bitcoin forum, bitcointalk.org, which currently has about 500,000 members. There's also a subreddit for Bitcoin with about 160,000 readers. We have many Facebook groups for Bitcoin. Each country has several groups. In Israel, we also have several Bitcoin Facebook groups. The biggest has about 4,500 people. We also have physical meetups all over the world. There are groups handled with meetup.com that have regular meetups. So in Israel, we also have a very large group. And of course, we also have conferences, international conferences. We had one in Israel last year. And every month, there is some big Bitcoin conference somewhere in the world. And last, I want to talk a bit about the government's approach to this whole thing. So right now, there's no place in the world where the legal status of Bitcoin is completely clear, but there are some advances in this area. So the US has been very active. There's been some guidelines from several regulatory bodies in the United States. Around the world, in Europe and elsewhere, many countries have addressed Bitcoin somehow. Most of them didn't really make a very clear statement, but we can see here some countries that have talked about Bitcoin in a way that is mostly positive, and here are some countries that talked about it in ways which are mostly negative. So that's more or less the situation, each country, of course, in its own way. And in Israel, we also have some things happening. So lately, in the past half a year, there's been a government team that consists of representatives from several offices that have been researching Bitcoins and figuring it out. And they have mostly finished their deliberation. And I think in a few weeks, we should be hearing from them some guidelines on how to use Bitcoin and how it's defined and what are the implications and so on. So Bitcoin is the money of the 21st century. It's money based on technology. Progress cannot be stopped, and I think that Bitcoin will continue to succeed. So thank you very much. And if we have some time, maybe I can take a few questions. Okay, if there are no questions, so that's it. So thank you very much.
טוב, שלום לכולם. שמי עוז צרור, ואני הארדוור דיזיינר בסטארט-אפ שלנו, במיזם שלנו, שנקרא EliptiBox. אני שמח ונרגש לספר לכם על המוצר המופלא שיצרנו, ממש חם מהתנור, זה בפעם הראשונה שאנחנו מפרסמים אותו, עכשיו בצורה פומבית. אני מאוד שמח להציג בפניכם. נתחיל מסיפור קצר, איך כל הסיפור הזה התחיל. אני אתחיל מסיפור. אז אנחנו קבוצה של אנשים שאוהבים ביטקוין, ובשנתיים, שנתיים וחצי, בערך 3 שנים שהתחלנו להתעסק עם הביטקוין, אז האחסון שלו, קודם כל זה דבר מופלא ומדהים, והאחסון שלו, תמיד ידד לנו בראש איך לאחסן אותו בצורה הבטוחה ביותר. יש כל מיני שיטות, כל מיני ארנקים, הבנו את הבעיה שקיימת הבעיה של security. אז היינו עושים כל מיני פתרונות שחשבנו בקולד סטור, זה אומר מחשב אופליין, שבו שמרנו את הארנק, וכל פעם שרצינו לעשות איזשהו תהליך, היינו צריכים לפתוח את הארנק ולהוציא ממנו ביטקוין, זה צריך תהליך מאוד מאוד מסורבך. וזה גם חלק מהקהילה, אנשים שלא משתמשים בביטקוין, שמשתמשים בביטקוין מפחדים, זה לא נוח להשתמש בזה, הם מפחדים מהקלות שאפשר להגיע לזה. אז הבנו שמדובר פשוט לנו זה צעק באוזניים שצריך ליצור חומרה מיוחדת, שהיא תאפשר אחסון של הביטקוינים, ארנק ביטקוין חומרתי. שם בא הרעיון. אז עכשיו אנחנו מבינים שיש שני דברים מאוד, מאוד קריטיים אצלנו. שני דברים היו לנגד עינינו. אחד, זה security ברמה גבוהה ביותר שאפשר להשיג בחומרה הזאת. והדבר השני, פשטות למשתמש, שקל לעבוד עם המוצר הזה. אז עם שתי הדברים האלה לנגד עינינו, התחלנו לפתוח במיזם וממש לחקור ולהתחיל לבנות את החומרה הזאת. אז אני אדבר קודם כל על האתגרים שעומדים, הפריצות שנמצאת ברשת, אני אסבר על החסרונות שלה וכמה זה קשה, וכמה התקפות, כמה סכנה קיים בעולם הזה. אחר כך אני אתאר את הפתרון שלנו שנותן מענה לזה, ואציג את זה כפלטפורמה. לא מחייב רק להיות, המוצר שלנו הוא לא מחייב להיות רק ארנק ביטקוין, הוא פלטפורמה לכל דבר. אנחנו מספקים תשתית איתו, אנחנו נדבר על הכל בצורה מורחבת, אבל המוצר שלנו לא חייב להיות רק ארנק ביטקוין, הוא גם פלטפורמה. פלטפורמה לפיתוח לכל העולם IoT. ואחר כך אני אציג את זה גם לדבר על איך זה משמש כוולט, כארנק של ביטקוין. אז כמו שאתם מכירים, בחוץ שם העולם מלא בהתקפות, אז אני רק אעבור ככה על התקפות שיסביר למה זה כל כך מסוכן. אז יש התקפות סייבר, זה המלחמה הבאה, סייבר. וכמו לדוגמה code injection, שזה בעצם בעיה מאוד קשה שאפשר יהיה לשתול קוד בחומרה, לשתול קוד זדוני מרחוק, שיכול לגרום להרס רציני מאוד ולמשוך משם בסופו של דבר את אותו סוד שאנחנו רוצים לשמור. ויש עוד הפגיעות של ה-USB היום, שאפשר לחבר אותו ואפשר להתחבר, הצורה האוטומטית שאפשר להתחבר ב-USB, גם מהווה חיסרון משמעותי. עוד יש מספר דברים, כמו hardware טרויאן, היום אפילו החברות עצמם שעושות את הצ'יפים, שותלים בפנים, בתוך הצ'יפים עצמם, קוד זדוני שמערעור מרחוק אפשר להגיע אל אותו קוד זדוני שיפעיל את ה-IP core שאפילו נמצא שם, ופשוט גם החברות עצמם עושות את הדברים האלה. כל הסיבות האלה, ו-side channel attack, כל הדברים האלה הם פשוט צעקו לנו שאנחנו צריכים לדעת להתמודד איתם. זה עולם הבעיה. אנחנו הבנו שפה יש בעיה קשה מאוד של security, שאנחנו לא מתפשרים עליה. לא מתפשרים על הבעיה הזאת. אז איך בעצם הפתרון שלי, איך הפתרון שלנו בעצם נותן מענה לבעיית הסקיוריטי, אנחנו הבנו שצריך לעשות hardware. הבנו שהפתרון הוא hardware משלנו. hardware שהוא יכול להיות תחליף לכל האחסון בתוך הארנקי אופליין למשל, אז הצורה החומרתית שלנו תיתן מענה ותיתן הגנה בפני אותם בעיות שהזכרתי. אני אסביר ככה בקצרה, אני תיכנס מאוד לעומק איך אנחנו עושים את זה. אז כבר ברמה הפיזית, ברמת הבורד, אנחנו נותנים מענה, ברמת החומרה עצמה, וגם ברמת החומרה שלנו כוללת כמה קריטריונים שנותנת בסוף מענה לבעיה הזאת. אחד, על ידי firewall, מה שעושים הפרדה. יש הפרדה בין ה-black side, שהוא ככה מכנים אותו, התווך הפרוץ, שכולם ניתנים, אפשר להגיע אליו, הוא פרוץ דרך הפלאפון למשל, כמו בלוטוס, שהוא ממשק פרוץ, הוא גם USB, הוא ה-black side, הוא החלק הלא מובטח, והחלק המובטח הוא החלק של הקריפטו, שם מתבצעת. הסוד שלנו שמור שם, לצורך העניין כמו בארנק, החתימה מתבצעת בתוך החלק האדום, והצד הזה הוא מאוד מאוד מובטח. אנחנו דואגים, בשיטות שאנחנו יודעים להכיר, מתמחים בהם, לדאוג לזה שהצד הזה יהיה מובטח. עכשיו, איך אנחנו עושים את זה? אנחנו משתמשים ב-firewall. עכשיו, זה לא firewall רגיל, זה firewall חומרתי שלנו. זה ממומש על FPGA, שמה שהוא יודע לעשות, אפשר לראות בצורה פשוטה, שמהקלאוד, מהאינטרנט מגיע המידע, ועובר דרך ה-firewall הזה. אנחנו יודעים ממש עם פיצטה כדי ממש להתמודד עם אותם התקפות של סייבר, כמו התקפות מרחוק. אנחנו יודעים באמצעות ה-firewall הזה להתגונן בפניהם. אנחנו ממש בודקים את רמת המידע שעובר, ורק מידע שמורשה עובר דרך ה-firewall ונכנס אל ה-red zone. זה מונע כל מיני באגים שיש בכתיבת קוד אפילו, של החומרה. אפשר לחסום את זה על ידי בדיקה של הפקטות עם אותו firewall, ולמנוע כל מיני התקפות. כמו למשל, כל מיני פרוטוקולים שמנסים, קודים זדונים שמנסים להיכנס, אנחנו יודעים איך לחסום אותם דרך ה-firewall הזה. ה-firewall הזה בעצם מאפשר ליצור ביחד עם החומרה שבאמת אני אזכיר, ליצור את האזור הבטוח. בנוסף ל-firewall יש לנו עוד התמחויות שלנו, ואנחנו יודעים לעשות את ההארדוור, את אותה החומרה. איך אנחנו עושים את זה? יש כל מיני תופעות של channel text side, שמה שקורה, אנחנו יודעים לבודד. יצרנו מעבר ל-firewall החומרתי שיש לנו, אנחנו גם יודעים את זה בטכניקות חומרה, שיודעות לבודד את עולם הבעיה. איך אנחנו עושים את זה? כל מיני שיטות שאנחנו מכירים, כמו RF Shield, עוטפים את המוצר ב-RF Shield, שמונע בעצם מקרינה אלקטרומגנטית לצאת החוצה מהמוצר, ככה שמישהו שמרחוק רצה להזין ולתקוף את המוצר, זה ימנע ממנו, מה שיוריד את הסיכון שזה יצליח. יש לנו שליטה על כל נושא הפאוור של הכרטיס. זה גם מוריד את הסיכון, אנחנו יכולים להדליק ולכבות את הפאוור בהתאם לזה, ואז גם למנוע זליגות לפאוור בעת יצירת התהליך של הקריפטו. יש לנו ממש, אפשר לראות בצורה מאוד ברורה, את ההפרדה הפיזית בכרטיס בין הצד השחור, הצד הלא מבוטח, הצד הלא בטוח, לבין הצד הבטוח, הצד האדום. ממש הפרדה פיזית, הפרדת אדמות, הפרדת מתחים, הכל נעשה במקצועיות שרכשנו לאורך שנים, וההפרדה הזאת ממש יוצרת חסינות לאותן התקפות שדיברתי עליהן. אז כמו שאמרתי, מדובר בחומרה, אני אתאר עכשיו את הפיצ'רים של אותה חומרה, שיכולה לשמש מעבר לארנק ביטקוין כפלטפורמה לכל סביבת הפיתוח שלכם, לאיזה מוצר, אם יש לכם רעיון, זה פשוט דבר אדיר, שיש בו הרבה פיצ'רים שיכולים לעזור לכם לפתח ולהיות אפליקציות, מעבר לארנק ביטקוין. אז מה יש בו? הוא פשוט פיצ'רים מטורפים, אני באמת אעבור על כל אחד מהם. החיבור אליו, העבודה איתו מאוד מאוד פשוטה. ישר פלאג אנד פליי, יש את הבלוטוס שישר מתחבר אל הסמארטפון, אני אסביר את זה עוד מעט איך זה קורה, והתקשורת מולו מאוד פשוטה. בתור לך כמפתח, לכם כמפתחים, לעבוד ולהשתמש בזה. אפשר לקנפג אותו לפי היישום שלכם, וגם את האפליקציות שאפשר להשתמש בזה הן מגוונות ושונות. אז אני אעבור על הפרמטרים של החומרה, למה אני כל כך אומר שהחומרה הזאת חזקה. אז פלטפורמת העיבוד, בתוך הפלטפורמה יש יחידות עיבוד, זה ה-ARM, זה אותו מעבד, מעבד קורטקס מסוג ARM, כמו שאתה מכיר, כמו שגם קיים בפלאפון, שאפשר פשוט לפתח עליו בצורה מאוד פשוטה, יש קודים שלו, יש לו קודים שאפשר להוריד אקזמפלים אליו, והוא בא עם זיכרון גדול, 500 קילו בייט וגם 64, ודבר נוסף החזק הוא בעצם הקריפטו, הוא המעבד קריפטו, יש לו סביבה חומרתית שמאפשרת אותה, אני גם אגע בה, אבל המעבד עצמו הוא מעבד קריפטו שמאפשר לבצע את החתימות. עכשיו, הדבר השני זה ה-FPGA, יחידת העיבוד השנייה, זה ה-FPGA שהיא בעצם ה-firewall שמקודם הזכרתי, היא היחידה החזקה. היא היחידה החזקה שיוצאת את ההפרדה בין העולם השחור, בנוסף לדברים החומרתיים שלנו, בין העולם השחור לעולם האדום. אז ה-firewall שלנו הוא מבוסס על FPGA. בנוסף יש לנו זיכרונות, הפלטפורמה מספקת זיכרון למשתמש. יש שם את הפלאש 256 מגה וגם SD קארד. למפתח אפשר, באפליקציה הזאת אפשר, בפלטפורמה, לשמור דברים שהוא מעוניין לשמור, כמו לוגס, כמו כתובות. באפליקציית, ביישום שלנו, כמו שאמרתי, אנחנו מכוונים לשתי כיוונים. יצרנו פלטפורמה בתוך הכיוון שיכווין אותנו, זה ארנק של ביטקוין, אבל בעצם מעבר לארנק הזה הוא גם פלטפורמה. אז ביישום שאנחנו מפתחים כארנק, אז אפשר להשתמש במיקרו SD קארד כגיבוי, כיצירת גיבוי של הארנק. אז מאוד ורסטילי, מאוד אפשר למצוא איך לעבוד עם הפלטפורמה הזאת, לא רק כארנק ביטקוין. אני אדבר גם אחר כך בסוף, איך אנחנו לוקחים את הפלטפורמה ואיך הממשק יעבוד בתור ארנק ביטקוין. אז כל הקונקטיביטי שלו, איך הכרטיס מדבר החוצה? הכרטיס מדבר החוצה בכמה אופנים מאוד נוחים למשתמש. הראשון מביניהם זה הבלוטוס, בלוטוס 4, הוא לואו פאוור. זה גם שכל המוצר שלנו הוא מאוד לואו פאוור. יש לו סוללה והוא יכול להיות בלי טעינה שנתיים אם לא משתמשים בו, וגם יכול לבצע עד 1,000 טרנזקציות. הוא צורך מאוד, תכננו אותו ככה שהוא צורך ממש מעט סוללה. אז הבלוטוס לואו פאוור הוא תקשורת מאוד מתאימה ליישום הזה, וגם קל לחבר אותה למקומות אחרים. USB, אנחנו גם תומכים ב-USB, עוד דרך קלה לחבר את המוצר שלנו ל-PC, לדברים אחרים שמדברים ב-USB, ואנחנו מספקים הבטחה גם ב-USB, כמו שדיברתי שהיא פגיעה וקל מאוד להתחזות ל-USB. אז אנחנו פותרים את זה, ויש עוד חיבור מאוד חשוב אצלנו שאנחנו מאפשרים בחומרה שלנו, שזה מחבר מיוחד מובטח, שיאפשר בסופו של דבר לקחת את הפלטפורמה הזאת ולחבר אותה לפלטפורמה מובטחת אחרת. למה אני מתכוון? לצורך העניין, יש לנו איזשהו בית חכם, או אפילו כספומט, שאנחנו רוצים להתחבר אליו רק מה שאנחנו רוצים, אני רוצה לעשות, להעביר מידע שעובר בעולם השחור, בעולם הלא מאובטח, אל אותה אפליקציה שהיא דורשת את ההבטחה הזאת, האפליקציה יכולה להתחבר דרך הפורט המאובטח שלנו. אז זה גם משהו מאוד חזק, שאנחנו מעבר ל-USB ולבלוטוס, אנחנו נותנים עוד פתרון חומרתי להתממשקויות של עוד חומרה נוספת, קיימת. הוא רוצה בית חכם שרוצה עכשיו להתחבר אל הענן, ויש לו כמה דברים שהוא צריך להפעיל, הוא יכול דרך המוצר שלנו לתקשר בצורה בטוחה. יש במוצר, כמו שדיברתי מקודם, גם פיצ'רים של אותנטיקציה. למה אני מתכוון? כמו שאמרתי, אנחנו מאוד מקפידים על יכולת זיהוי אחידה, יכולת זיהוי בצורה מאוד ברורה, על ידי, נגיד, פינגרפרינט, יש לנו גם. פינגרפרינט זה פשוט משהו ביומטרי ששייך לבן אדם בעצמו, כדי בתהליך ההזדהות, מה שקורה זה משהו שהאדם, שהמשתמש יכול לגעת במוצר, ויש לו באמצעות הפינגרפרינט, הזיהוי הביומטרי שלו, רק לפתוח אותו. בנוסף, יש לנו עוד אותנטיקציה של True Random Number Generator, משהו מאוד חזק לעולם הקריפטו. אנחנו יודעים לייצר משהו שהוא True Random Generator, זה מספר רנדומלי אמיתי, שנוצר מתופעה פיזית, באמת מספר רנדומלי, זה גם משמש את זה בעולם הקריפטו, זו תכונה מאוד חזקה. ועוד דרך לאותנטיקציה זה מסך. למה אני מתכוון? למה זה חזק העניין הזה? כי כל פעולה שתתבצע מול המוצר, כמו למשל טרנזקציה או תשלום או משהו שקורה, אז דרך המוצר שלנו אנחנו לא ישר מעבירים לפלאפון, ואז יש מישהו זדוני שמתחבר ומאשר בעצמו. כל פעולה כזאת, לפני שנוצר הקריפטו, תוצג על המסך. ואז המשתמש בוחר אם לאשר או לא, בהתאם לפני לצורך העניין חותם, לפני שהארנק חותם לפי הכתובת, הוא קודם כל בודק את הכתובת, רואה כמה כסף מועבר, שהכתובת היא אמיתית למי שהוא רצה באמת לחתום, ומעביר את זה. זה החוזקה של התצוגה. יש עוד רכיב שעוזר לנו מאוד בכל האותנטיקציה של הפרוטוקול, זה הדדיקט, זה מה שהוא עושה. כל החתימות הדיגיטליות הוא יודע לעשות עם הרכיב הזה. אז אני אדבר עכשיו על EliptiBox ככלי למפתחים. מעבר כמו שאמרתי, המטרה שלנו בהתחלה לצאת עם המוצר כארנק בביטקוין, אבל יצרנו בדרך פלטפורמה, אז הפלטפורמה הזאת מאוד מאוד נוחה למפתח. למה? בגלל שאנחנו נותנים כלים מסביב מאוד נוחים למשתמש לעבוד עם המוצר הזה. למה אני מתכוון? ה-SDK שלנו הוא פתוח, הוא open source. אנחנו מאמינים בחוכמת ההמונים, אנחנו מאמינים שכל אנחנו לא מסתירים שום דבר, אנחנו בוטחים במה שאנחנו רוצים, אנחנו נותנים לכם ככלי להשתמש באופן סורס של ה-SDK. גישה לכל התממשקות אל הפלאפון, התממשקות אל המחשב לצורך העניין, הכל הוא חינם. אנחנו גם נותנים את המוצר עם דוגמאות, רק תבואו עם רעיון ובואו תתחילו לפתח. ממש ככה. ההתממשקות של זה פשוט יכולה להיות peer to peer, זאת אומרת שאני יכול לקחת את המוצר, לחבר ולהעביר מידע בין מוצר למוצר. היא יכולה לעבור דרך מהמובייל ל-PC, זה מאוד ורסטילי, לחבר בין הדברים עם המוצר, והכל בצורה מאובטחת. אז זה החוזקה שלו, אחת החוזקות שלו. עכשיו אני אדבר על המוצר כארנק ביטקוין. אני אסביר את הקונספט. הקונספט הוא מאוד פשוט. האינטרפס של השימוש בארנק הוא מתבצע מול הפלאפון. הפלאפון מחובר לקלאוד. כל הממשק, הבחירה של הכתובת, לצורך העניין, בן אדם פותח את הפלאפון, הוא רואה את השם בספר טלפונים שהוא רוצה להעביר אליו את הביטקוין, בוחר, מפעיל את האפליקציה, המידע עובר דרך הבלוטוס, בוחר כמה כסף הוא רוצה להעביר אליו, לפי הכתובת, האפליקציה מעבירה דרך הבלוטוס אל ה-firewall שלנו, ה-firewall מסתכל, בודק שזה, אין התחזות והפקטה היא נכונה ועומדת בכל הקריטריונים הגבוהים שהצבנו, כדי שזה מובטח, ומגיע אל התצוגה. פה זה משהו מאוד חזק, שיש פה אותנטיקציה מול התצוגה, זה מעבר לממשק, יש פשוט האותנטיקציה שאתה מאשר, לפני שהביטקוין עובר מאחד לאחד, אתה פשוט רואה ואתה צריך לאשר את זה בעצמך, וזה לא קורה, אי אפשר להתחזות לזה, כי לפני שהמיקרו מבצע את החתימה, פשוט מציג, ואתה צריך לאשר, פשוט מציג את הכתובת שרוצים להעביר אליה. ואז המשתמש בודק, רואה שזה הכתובת שהוא רוצה להעביר אליה, את הכמות הנכונה, ופשוט מאשר. once הוא מאשר, פשוט הקריפטו ברד זון, במצב הבטוח שלו, במצב המוגדר לו, שהוא כסייף, פשוט מייצר את הקריפטו, חותם, ומחזיר חזרה דרך ה-firewall החוצה. יש עוד דרך לאפליקציה, פשוט גם עם טביעת אצבע. ככה גם יגנבו את זה, פשוט טביעת אצבע שבמוצר תאפשר את האישור, לצורך העניין. זהו, זה המוצר, ככה אמרו לי גם ב-20 דקות להציג אותו. אז אני אסכם. המוצר, מעבר לזה שהוא פלטפורמה, מעבר לזה שהוא באמת יוצר בהתחלה במחשבה כארנק ביטקוין, הוא פלטפורמה. אנחנו מבינים שהעולם הוא לא בטוח בחוץ. יש התקפות סייבר כל הזמן. שמענו לא מעט סיפורים שנשדדו בורסאות. EliptiBox למשל, סכום עתק נגנב משם. 450 מיליון דולר. ואנחנו מבינים שסקיוריטי אמיתי מתחיל בחומרה. אנחנו מבינים את זה. סקיוריטי אמיתי מתחיל בחומרה ואנחנו יודעים איך לייצר אותה. יצרנו את הפלטפורמה, את החומרה הזאת. אחרי סיעור מוחות של 2 ועכשיו היא כבר בהישג יד. אנחנו לא מחביאים כלום, הכל הוא open source, אנחנו ממש פותחים במוצר שלנו. אתם יכולים לבוא ואנחנו מאוד מתוקבקים, יש לנו אתר, להיכנס שם, לקרוא על הדברים, לתקבק, לשאול שאלות. אנחנו מאוד נשמח שיקחו את הפלטפורמה וליצור שיתופיות איתכם. ובזמן הקרוב יהיה מיטאפ בזמן הקרוב יהיה מיטאפ ואנחנו פשוט ניתן את הארנק שלנו כפלטפורמה לפיתוח. פלטפורמה לפיתוח עם כל ה-SDK שדיברתי עליהם, ניתן אותו כפלטפורמה ורק תתחילו לעבוד איתו. זה בהישג יד וממש כדאי להתחיל לעבוד איתו. זהו. תודה רבה.
אפשר לשאול שאלות?
כמובן שאלות.
אנטיווירוס מעדכנים כל הזמן, כי כל הזמן יש, אתה יודע, התקפות חדשות. חומרה קונים פעם אחת ומה זה? זה לכל החיים או...
יפה, שאלה טובה. אז קודם כל אנחנו מאפשרים עדכון של פירמוור מהחוק. אפשר יהיה להפעיל, גם דרך ה-SD card, יש ממשקים בטוחים שאנחנו מוצאים, אפשר יהיה לעדכן את הפירמוור. אז גם אם משהו עכשיו, הפירמוור שלנו גם אופן סורס, ברגע שימצאו איזה פרצה, ישר אפשר יהיה לעדכן את הפירמוור. עכשיו,
לעדכן את החומרה או לעדכן?
הפירמוור, כן, חומה. פירמוור זה חומה, ה-FPGA, אותו firewall שלנו, זה תוכנה, אבל זה מימוש חומרתי. זה כאילו, אפשר יהיה לעדכן את הפירמוור שלו, גם של המיקרו. אין בעיה לעדכן פירמוור. אם נמצא איזה משהו, כמובן שאנחנו, יהיה אפשר לעדכן. אין בעיה לעדכן את זה. עוד שאלות?
מחיר?
מחיר זה תלוי כמות, אנחנו כרגע, בגלל שרק עכשיו התחלנו, בערך יעלה כמה, 100 ומשהו דולר, מחיר מטרה, אבל כשנתחיל לעשות את זה במאס פרודקשן, אנחנו נגיע למחירים זולים מאוד, של כמה עשרות דולרים. כרגע אני אעדכן, פשוט ממש לפני שבועיים הגיע הכרטיס, עכשיו אנחנו, בסוף השבוע, ביום הראשון, כבר הכרטיס יישלח לרכבה, רכיבים, יגיע הרכיב, בינתיים הושקעו מאמצים, אחרי שסיימנו את הפיתוח, בכל עולם התוכנה שלו, כל ה-SDK, יצירת ה-SDK, יצירת ה-Open Source, להראות למשתמשים מה עשינו עד עכשיו, כבר הגענו למצב שאנחנו מצליחים בעולם הביטקוין לחתום, לעשות טרנזקציה ולחתום בה בתוך המוצר, וזה עובד. ואנחנו בקרוב, אני מאמין שאנחנו נצא למאס פרודקשן כבר ברבעון האחרון של השנה.
המיטאפ, איפה תפרסמו עליו?
סליחה?
על המיטאפ, איפה תפרסמו?
קודם כל באתר.
שלכם.
של האתר שלנו, וגם בקהילה של הביטקוין, וגם אנחנו נופיע שם. אז גם כדאי לעקוב, תכנסו לאתר, ותעקבו אחרינו. תעשו משהו עם המידע הזאת, תספרו לחברים שלכם. באמת, זה משהו שבוער בי, כי באמת אחרי הרבה זמן של פיתוח, פשוט תיכנסו תדברו על זה, תספרו לחברים שלכם, תציפו אותנו בשאלות, בואו, תתפלפלו איתנו, תאתגרו אותנו, כי באמת בשביל ליצור את זה אופן סורס, שיהיה ממש חזק ובטוח שהקהילה תכיר את זה. ממש משהו שאנחנו, מאוד חשוב לנו, בגלל זה אנחנו גם נהיה במיטאפ, ניתן לזה פיתוח, סביבות פיתוח, או מה שידרש, גם כמובן יש שם לפנות אלינו פניות לשיתופי פעולה, אנחנו מאוד נשמח, מעבר לקהילה. יש עוד שאלות?
Okay, so thank you very much for having me here. My name is Ben-Sasson. I'm a professor at Technion, Israel Institute of Technology, and I want to tell you about some research that we've been conducting, reducing to practice various kinds of novel cryptographic protocols that could be relevant also to things like the Internet of Things, though I think it would really need some strict security requirements to deploy it right now in that scenario. And as you can see, I'm going to tell you about ongoing works and previous works with a pretty large set of collaborators. There's a large team at Technion and collaborators in Johns Hopkins, Tel Aviv University, MIT, ETH Zurich. Okay, so what is this problem of computational integrity and privacy? So it's really a pair of problems, and it's best to describe them using this picture of Alice and Bob. So suppose Alice has a program that she would like Bob to execute, and she's interested only in the output. So she wants to send the program to Bob, and she wants to know the output. But the problem is maybe Bob wants to cheat. Maybe it's something about his financial status, about his health condition. Can she trust his output? Now Bob, on the other hand, is willing to execute the program, and maybe even he's honest, but he doesn't, and he wants to convince Alice that he's computing with integrity, but he doesn't want to reveal the inputs to that program. That could include passwords, financial information, his wallet, medical information. So he's willing to compute and reply honestly, but how can Alice trust him, and how can he relay the answer and convince Alice that he's telling the truth? And syncness means that we would like this whole thing to work very efficiently. So Alice wants to spend no more time than reading something that's as long as the program. She wants Bob to compute. But the running time of the program could be much, much longer than the description of the program, because it could have these loops and iterations and other things. So it seems to even to contradict Turing's undecidability of the halting problem, which implies that you cannot really understand what a program does without executing it always. So if Alice doesn't trust Bob and she still wants to know the answer, how does she even know that the program halts in time t if she runs for much shorter time? So it turns out that there are cryptographic and other methods using randomness and interaction between parties to solve this problem. And I'll do fast forward to the result. There are ways in which Alice will ask, in addition to the output, to be provided with a proof, which is a short string that will satisfy the following properties. So completeness, if the output is correct, then Bob can produce a proof which will be accepted by Alice. Soundness means that if Bob is trying to cheat, then he will not be able to produce a proof that convinces Alice. Efficiency means that producing this proof is efficient and can be done easily. if Bob is honest. Succinctness means that both the proof and its verification time are very short, and you would want it to be non-interactive and publicly verifiable, meaning that anyone looking at it, even if it's not Alice, can use it. In particular, Alice doesn't want to use any trapdoors or randomness to generate it. And you want it to be a proof of knowledge, which means that when Alice sees it, she knows not only that there exists some input that would lead to that output, but that Bob actually knows it. So he knows his financial information or passwords, which led to that computation. And such magical proofs are called sometimes non-interactive zero-knowledge proofs. They're called succinct non-interactive zero-knowledge proofs, computationally sound proofs, or I'll use the name that we use in many of our papers, SNARK, which stands for succinct non-interactive arguments of knowledge. So there are two flavors of computational integrity and privacy. The one that was first investigated has trustless setup. And it starts with this marvelous work by Babayan Moran and by Goldwasser, Mikali and Rakov from the late 90s, and then a lot of beautiful theory afterwards, which essentially shows that the problem can be solved using things called PCPs, transparent proofs, and various cryptographic compressions of them. There is a way that for any given program in the world, Bob can convince Alice by means of a proof that he actually has computed the program and has the correct answer, and Alice can verify this thing without executing the program or without running any protocol that takes longer than roughly reading that program. Okay, and moreover, at Skipper Lab, at this collaboration that we're conducting, we're actually working on implementing these things, but it's not quite ready yet. There's a different flavor that's more recent. It also stems from the theory of interactive proofs. And here, we're going to allow a one-time setup phase done by a trusted key generator that then publishes two keys. One is used only for verifying proofs and one is used for constructing proofs. And then that generator disappears. So the generator uses some randomness, computes something, publishes two proofs, one for verifying, one for proving things, and then disappears. Okay, so it's a little more strict than the trustless setting. I mean, there's another assumption here that you can have this generator, but once this thing has been published, then it disappears forever. I mean, the trusted generator. And this goes back to work by Ishai Kushilevich-Ostrovsky, who showed that these things can lead to much more efficient protocols. And then there are various improvements using elliptic curve cryptography and quadratic arithmetic programs. And these things have actually been implemented. The first implementation is in a system called Pinocchio by Parno, Gentry, Haywell, and Reikova. And there's another implementation that came shortly after by our team, joint with Chiesa, Tromer, and Virza from about 2 years ago. And this has even been used in Zero Cache, which I assume some of you have heard about. And in our systems, in these systems, the verification key is pretty short. It's 1 kilobyte long, and the proving key is 1 gigabyte long for Zero Cache. So it's much longer. You can see 1 million factor difference between verification key and proving key. And we conduct this research within this collaboration that started in 2010 with Alessandro Chiesa, Daniel Genkin, and Tromer. By now we have 14 active members and counting. And our goal is to implement protocols that allow you to succinctly prove computational integrity and privacy for any program. So Turing-complete things, programs like written in C or C++. And we want to ascertain integrity of the output by proofs, and we want them not to compromise the privacy of auxiliary inputs, and we want them to be succinct. And you can read more about this and see our academic publications at skipperlab.org. Now, this all works. A good way to think about how these snarks and proofs work is the following thing. Suppose you can reduce whatever it is you want to compute to a proposition that outputs only one bit, true or false. So what you have is a language, to use the terminology of computer science. And this language, or this computation, can have two inputs. X is the explicit input, public, everyone can see it. Could be, for instance, the hash of your password or some hash of your wallet identity or something like that. But there's also the private input, W, this witness, and that's your private information. Let's say it's the password itself. It's your financial data. It's all of your Bitcoin transactions. And as long as you can construct some statement that basically says there exists a witness such that if you plug it in with the explicit input, the output of that computation will be true, then you can construct a snark for it, a proof system for it that will generate proofs that are valid only if you supplied a W that causes that circuit to output true. And you cannot cheat, even in a single bit. Okay? If you do not know such a W, you cannot reach true. You don't know how to reach it. There is no effective way that you can get a proof that will convince others. So any computation, reasonable, efficient computation, can be reduced to such circuits. It's a very general thing. I want to tell you about two applications that you could reduce things. So one is zero cash, and it's this thing that we already published. It's a decentralized anonymous payment system on top of Bitcoin, and it solves Bitcoin's anonymity problem. This is joint work with Chiesa, Garman, Green, Myers, Tromer, and Virza from 2 years ago. And I want to give just one simple Internet of Things related example. So suppose you have a nuclear plant, and that's Alice, and she installs some chip that measures the pressure in some pipe, and that chip or sensor is now screaming, oh, there's an emergency, we have to do something. Can Alice trust it? So I want to show that these two things can be reduced effectively to systems of NP statements and used to prove computational integrity while preserving privacy. So when should I end? I'll try, okay, 10 more minutes, I'll do it. So anonymity in Bitcoin. Imagine, I assume you know what Bitcoin is, and assume that Bitcoin is the only currency around, salaries, shopping, everything is done in Bitcoin. So suppose I got my first paycheck, and it looks something like this. So what really has here is there's the payer's ID, my company's pseudo ID, which is some cryptographic key. There's the transaction amount sitting in the middle. And then there's my own pseudo ID. Then I go and buy myself a cup of coffee. So I use the very same pseudo ID and I make a payment. Now both of these transactions get published on the blockchain and everyone can connect the dots. And now, for instance, the person at the coffee shop knows how much my salary was, or can at least guess this, and my employer can know where I like to buy my coffee. And this is just by using a browser. Of course, if you do more analysis, you could get deeper understanding of what's going on in Bitcoin. And the point is that the methods of analysis only get stronger with time, but your Bitcoin history is publicly saved forever. And that's a problem. So now you could say, well, I don't care if my employer knows that I'm buying coffee. Why should I care? But this actually will limit Bitcoin adoption because big businesses do care about competition and they don't want their information revealed. And on a deeper level, this is a threat to Bitcoin fungibility because if you accepted a coin, you may worry if this coin wasn't ever involved in something that's illegal or someone may have a claim on it. And because the whole history of transactions is open, you never can quite trust that this coin will really be valid, even if you accepted it in a completely legal way. Bad coins could taint good ones, and that's bad, and you don't want that in a currency. So there are quite a number of solutions because of this problem of lack of anonymity. The first one is just to replace your pseudo IDs as often as possible. This doesn't quite, make the problem of connecting the dots that much harder. You could use a mix where everyone brings a bunch of coins together to one address and then that address dispenses them. This has its own problems. You have to trust the mix. It's prone to denial of service attacks and so on. You could trust a large party like a wallet or empty GOX, but that has its own problems. Or you could use, there have been previous protocols that solved half the problem. They could hide payer and payee, but they didn't hide payment amount, and they also had some scalability issues, practical ones. So let's go back to our solution. To achieve anonymity, what you really want to do is, first of all, hide the payment amounts, and you want to hide or break the links between the pseudo IDs so that basically you see nothing. You just see that something happened, but you don't know who paid, whom, what, or how much. And the point is that actually achieving anonymity is quite easy, because what you can do is you could basically encrypt or commit to information. For instance, you could take some collision-resistant hash function like SHA-256 and just take that transaction and just publish a hash of it. The point is that everyone can see that something has been committed to, but if you don't know the preimage, it's going to be very hard or impractical to guess that. So you could see some hash of a transaction, but you don't know what really happened. Now that's an easy way to achieve anonymity, but the problem now becomes integrity, because maybe I could hash a payment that pays myself, 50 bitcoins that I don't happen to have. So the problem really is now integrity, and this is where computational integrity proofs and privacy kick in. So when all is hidden, what would you like to do? Alice wants to send Bob some bitcoins. So, and Bob's wondering, is this valid? What you really do, let's say with banks, is Alice goes to some banker and she says, well, look, I just received my salary and I haven't spent all of it, so is that okay? And the banker will sign it. But we all know that bankers don't really, it's not humans that check these things anymore, it's really computer programs. So the point is that Alice can execute or simulate that computer program and then prove to Bob that the computer program said that she has sufficient funds. And this is what we do. So Alice will send a transaction, actually the hash of a transaction, and she will append to it a proof that she has funds and everything's okay. Now, what kind of proof do you want? You want it to be a zero-knowledge proof that reveals nothing about the pre-hashed information. You want it to be non-interactive. Anyone can verify it just by reading the proof. You want it to be succinct so that it doesn't blow up the size of the blockchain. And you want it to be a proof of knowledge, so it should convince Bob that Alice knows the keys controlling the funds she's sending him. And such things are called DK snarks, also non-interactive zero-knowledge proofs. Where do we get them? Well, there's a lot of theoretical work, and there's some working prototypes, including by our team. In particular, this paper that we presented 2 years ago shows that you could get snarks for any circuit and verify them by proofs that are 230 bytes long and can be verified in 5 milliseconds. And this is, by the way, public. This is open sourced under an MIT license. You can play with it, build your own circuits and propositions that you would like to use. And then the question is, how do you use this in a payment system? So I'm not going to go into all details. I'll just give an example. So suppose each coin has a serial number that is hidden under a SHA-256 hash. So what you see as the coin, you see its hash, and that's a commitment to a coin. And the statement is, anyone who knows the preimage of this hash controls the coin. So when Alice wants to spend and pay to Bob, she'll say something like, well, I know the preimage of the hash, so I know the preimage of this coin commitment, and I'm presenting it for everyone to see, and because you see that I know this thing, the coin belonged to me, so I'm paying it onwards. But of course, this is going to reveal information, because now everyone sees that that coin belongs to Alice, and you can again connect the dots between payer and payee and amount. So what we're going to do is remember this whole description of circuits and so on and witnesses. So the explicit input is going to be seen by all, and there's going to be a witness that's private, and there is a computation, some circuit that checks things. And here we're going to use the NP statement, or the existential statement, that says there exists some witness that causes the circuit to accept. And a zero-knowledge proof is going to prevent any information being leaked about the witness. So let's go back to this system, and here's what we're going to do. Suppose that we took all previous coin commitments and we used what's called a Merkle hash to sort of commit to all of them at once. So there's this big database of coin commitments, a long list of them. And now what Alice does is she presents as the explicit input the serial number, which has never been seen in the past, and the root of the current Merkle tree that commits to all coins in the world. And then she proves that she knows some path going from some coin that's been, from some coin commitment. She's not going to tell which coin commitment that is. And that path leads from a coin commitment all the way to the root of the current database that describes the state of the world. And there is information hidden under that coin commitment, and she checked, that the funds there are legal, that there's enough funds to pay one coin to Bob, and so on and so forth, and the whole circuit is okay. And she just sends that proof. Now anyone who sees this knows that there's some coin that has been revealed that cannot be spent again because the serial number is now presented as part of the explicit input to the circuit. That's how you prevent double spending, but no one can link that just spent coin to who spent it or where it appeared previously. Now, this thing works, so it takes 46 seconds to generate this proof on a strong machine. It takes 6 seconds to verify. The proof is 288 bytes long, and you need this 0.9 gigabyte proving key to generate a proof. And that proving key involves a trapdoor that, if leaked, can be used against you to forge coins. So I just want to point out that in the bottom of the line, there's a fully green row that at Skipper Lab we're working on, and I hope that we'll be able to talk about it sometime soon, where you don't really need trusted setup as we currently do. And just last week, so we presented a paper that shows how you can distribute the trust in this trusted setup so that many parties can jointly generate the keys needed for working in the system. Now, I just want to say a few words about this Internet of Things application. So suppose you have a chip that needs to prove something to a central computer. So the concerns of the central computer, and this is tied to the Internet of Things, which is the theme of this conference. Alice may be wondering when she hears this alarm bell being sounded by Bob. So first of all, is it really Bob, or is it someone impersonating Bob who's sounding this alarm bell? And then there's the other question, which is Bob really measuring the world correctly? And finally, is Bob computing correctly, given that he's reading the inputs correctly? And when he's computing, will he reveal private information? Because it could be that that chip is measuring things like the retinal scan of people working in the facility, or voice patterns for biometric authentication, or chemical composition, which could leak information that you don't want leaked. So I just want to point out that the snarks can take care of the bottom two problems. You could use more crypto, and I'll say a word about it soon, to solve the first problem. And the last problem of, is Bob really measuring the world correctly, or maybe some enemy is now putting, heating up the sensor. That's something that you're going to have to solve physically. It's not something that you can do in software. So you could also prevent sensor impersonation, and this is something that we all do with smart cards and things like that. You install some non-extractable secret key on Bob's chip, and then you publish to the whole world a hash of that secret key. And now Bob can send proofs that will tie the computation that he's performing to the data he sees and to the particular key that is installed and you assume not extracted from his chip. And now you can really know that no one is impersonating Bob when Bob is saying that the pressure in that pipe is too high. So I want to sum up and say that Skipper Lab is working on implementing protocols for ensuring succinct computational integrity and privacy for general computation. We have some open source code that you're all invited to look at. We have a bunch of academic papers you're invited to read. We'll be posting more as things come along. We already used it for a number of things, including for constructing the first anonymous decentralized payment system, that's Zero Cash. And you could use it also for the Internet of Things in situations where you really, really are worried about security, cybersecurity. And follow us at skipperlab.org. Thank you very much.
if I understand correctly, regarding Internet of Things, computation can be carried on a server and be completely certain that this computation is true. I mean, completely whole.
Yeah, our solutions are software-based, so anyone with the correct inputs and the witness, this private information, and knowledge of the program that needs to be computed will compute it. Yes. Yes.
Anyone can be a witness, correct?
Sorry?
Anyone can be a witness. Whoever you define as a witness can be a witness.
Yeah, the witness is data, and the witness is part of the computation. So you take any circuit or any computation, and you can partition the input string into that thing in any way you wish and say, well, this part is input and this part is witness. And for any such partition, you can generate snarks and proofs. I mean, you first have to know what is the partition you would like. But usually it would be, you know, the password is part of the witness, the financial data is part of the witness, the public information is, let's say, the output of the circuit, or the fact if you qualify for some, you know, savings on some health insurance because of your health data.
What I meant, just to clarify, what I meant is not strictly about privacy, but to know that the computation that is being done is completely whole or complete. That means that if a machine cannot compute its own computation, sends out the machine, would that machine probably would need more power to prove, to check the proof, right? So you should,
verifying proofs is typically much easier and shorter and faster than generating proofs. So
big computation can be done outside the machine. And
right, you could outsource some computation to be done outside, and then
certainty.
Yes, with cryptographic certainty. Yes, that the output is correct. Exactly. Yes.
I don't know if this is a problem you want to solve, but using that much anonymity, you know, one can say that it's against what the society wants, right? If you use money for illicit purposes. Now, this problem exists also with cash, but is there a way that you could make it harder? I don't know.
So zero-knowledge proofs are, much like a lot of other things in cryptography, a tool.
Right.
You could use it for, and it's a very agile tool. You could, as I said, you could use it for any computation in the world, and you could bake it into any system, as long as the computation is efficient. So you could use it, you know, you could also define circuits that are used for auditing payments, or for proving that you only paid to parties on a white list, or that you paid your taxes as you should. Any computation that you can define, or any property that you can define explicitly using, in the end, a circuit and an algorithm, can be done, you know, using zero-knowledge proofs. So I often say this when I speak more at length about zero cash. It's going to be up to the society to decide what are the right policies that society wants to implement, and then I think that you know, zero-knowledge proofs can be used to implement a very wide range of them. But you're right. I mean, the other side is too little anonymity, and then Big Brother sees everything. So this is true for, there's this balance exactly, and it's going to be a matter of continuing debate. Thanks.
Keep it for that. So good afternoon to everybody. I'm Ali. I'm going to moderate this panel on Bitcoin and IoT. With me are Mark Smargon. Mark is currently the VP product and co-founder of Kolu, a startup aimed at revolutionize the Bitcoin 2.0 landscape. In the past 2 years, Mark focused on Bitcoin technology, exploring different use cases for both developer and end user point of view. He also founded BitGo COIL, a Bitcoin payment provider in Israel, and CreateX, a leading e-commerce provider in Israel. Mark has 15 years experience in web technologies and leveraging them in order to meet the market needs. Mark, welcome. Roman has graduated from software unit in Israeli Air Force. For the past 15 years has been developing software for the telecom and software industries, infrastructure industries in various companies. Found out about Bitcoin in 2012 and ever since has been dreaming of a world where Bitcoin is dominant financial technology. Recently has been part of the development effort of Ethereum and currently continues to implement new ideas on top of Ethereum protocol. Roman, welcome to the panel. Iddo Bentov is a PhD student at Technion who has been involved with the Bitcoin space since mid-2011, has written several academic papers on cryptography and Bitcoin, currently works on second proof of Bitcoin related projects at Cyprlab and the color coins at ChromaWave. Welcome, Iddo. And Meni Rosenfeld has been a Bitcoin enthusiast since early 2011, has established the Israeli Bitcoin Association, been part of the Global Bitcoin Alliance, and generally being a very nice guy. So welcome, guys. I'll give you each a couple of minutes just to introduce what you've been doing in the last, whatever, 2 years or so. And we'll move on to Bitcoin and IoT. So, Mark.
Hi. So I've been 2 years in Bitcoin, a little bit more, and for the past year I've been working on Colo. We got funded half a year ago, and we are currently 13 workers in Tel Aviv, near the embassy, not far from the embassy. Colo is a company that works in the Bitcoin 2.0 space. We try to explore how to use cryptocurrency not as a currency, how to use Bitcoin as a way to transfer value, how to use it for different use cases, for different applications, and we also are in charge of moderating and developing the colored coins protocol. One of the companies that works in this space, ChromaWave, is another company. We're currently 4 companies with different coloring schemes, every one of them, and every coloring scheme has its own pluses and minuses. The coloring scheme is how we exactly use the blockchain to issue digital assets. So I can give...
Colors are basically different categories of assets.
Yeah, it's like it's a metaphor for what we basically what we're doing is taking a Bitcoin dust, and which is Bitcoins that don't really have any value, satoshis, and we attach value to them by entering a specific by coloring the function of coloring, just inserting metadata into transactions of those, and we can say that the transaction represents a gram of gold, or a loyalty card, or a gift card, or some in-game currency, a currency you can create your own currency on top of the blockchain. You can.
What's the cost of operating such a currency on color coins?
Well, basically, the cost is almost the same in every implementation. It's the cost of mining fees. Sometimes you need to pay for mining fees for one transaction, sometimes for 2, based on what function exactly do you do. The cost is minimal. It's approximately, I think, half a cent. I don't know. Maybe Meni knows better.
So there is basically zero cost in establishing a digital asset on top of colored coins.
You have a cost of approximately, I think, I don't know if I'm doing my math correctly, about $1,000 for 1 million transactions, something like that. You do have a cost, so you can use. So spam on the blockchain is a problem, but it depends on the use case. If you want to use the blockchain to issue movie tickets, So it's not a problem. Half a cent is virtually nothing for this use case. But if you want to use the blockchain to, I don't know, post timestamps every 5 minutes of the document you're typing, so it could be verified on the blockchain. So yeah, maybe half a cent is a little bit problematic. But there are ways to maybe aggregate the ideas that try to achieve it. I think we're on the way to find really a way to aggregate those transactions and hash them into the blockchain so they could be verified and transferred. I don't know, what proof of ownership. You can create public ledgers for governments, ledgers with, for instance, company ownership. Who owns what, history of ownership.
So color coins can be used for identity and identity verification, basically.
Yeah, it's exactly the same way Bitcoin is used for identity. Colored coins can be used just adding functionality to the Bitcoin. And I can elaborate a little bit more of what we're doing at Colu. So
in a moment. Roland, you're working with Ethereum, basically. You're developing something similar. Ethereum is basically similar to Colu in what color coins are doing. Tell us about Ethereum and what you're doing there.
Yeah, so Ethereum born as an idea of, basically we was looking on this market of the Bitcoin, and everybody was excited by the option to transfer value from one peer to other peer and to be secured and also transparent to everybody. And the idea of Ethereum was to say, hey, everybody trying to do this stuff on top of Bitcoin, but maybe Bitcoin good as it is, and maybe this big experiment that started by Satoshi that became multi-billion economy somehow, maybe it does not have to provide all our needs. And maybe we can take a step backwards and try to design a network. We already know the value. We already see the necessity from the public. We already know that our audience outside there wants this. But maybe we can take this step backwards and design the network from scratch, taking in consideration all the pros of Bitcoins and trying to eliminate on the cons. So. This is the fundamental assumption of Ethereum, and Ethereum really does exactly this. It tries to build from scratch a peer-to-peer network that will provide you with option to develop any kind of program that will act on any kind of state, exactly as Bitcoin. Acting on some kind of balance, right? So what is a Bitcoin? Bitcoins keep a balance of everybody, right? So balance is one state. It's one small part of a state. And Ethereum trying to take a state, any kind of state. It can be a number of options you have. It can be a number of votes you voted for somebody. It can be whatever. And trying to take an algorithm that you design and make and ensure that this algorithm is going to run exactly the same way on all peers. Okay, I guess it's good for the intro. If there will be some questions, I will answer. Okay, some specific questions.
Iddo, you're working on Zipper Labs, if I'm pronouncing it correctly. Basically, your zero knowledge proofs, right?
Yeah.
Tell us a little bit about that.
Okay, about Skipper Labs. So that's the project that was the previous lecture about this succinct proof system, zero knowledge proofs that can be used. So one example was Zero Cash, a completely anonymous Bitcoin style system. The part that I'm more focused on is this next advance that is supposed to happen, where you don't need this trusted setup, and you can have these proofs where you don't need to trust anyone and can be used to be, and they are publicly verifiable by everybody. And the use case for those kinds of proofs that we are trying to actually implement is something that is quite famous in the Bitcoin space, that is now called side chains, where you have one system like Bitcoin, and you can now have another system that's maybe a little different. You want to experiment with new features, but you don't want to have all of this speculation where you start the coin and maybe nobody heard about it yet, and people are mining it, and then they want to sell a lot of the coins that they mined very cheaply because nobody else participated in the system. There a lot of speculation in this way, and if you have this idea of a sidechain, or what's called a two-way pegging, meaning that you can always transfer a Bitcoin into this sidechain, this other chain, and transfer a coin from the other chain back to Bitcoin. So they are always worth exactly the same, or approximately almost the same, except for transaction fees. So the value of a coin in this system is exactly the same as in Bitcoin, and you don't need to have a mining that is done separately on the sidechain, and you can do it with non-interactive proofs to transfer the coin between the Bitcoin main chain and the sidechain in a secure way. So that's what we are.
So you're basically trying to avoid what happened in 2014, where we had hundreds or maybe thousands of altcoins, basically, that don't necessarily provide anything new in themselves, but some people needed them or wanted them, and you're basically providing a better way to create those currencies, altcoins.
Yeah. So the hype with sidechain, there was a lot of hype by Adam Back and the guys who started it, like let 10,000s of chains bloom and whatever. So that's the vision, and okay, so we are still, in terms of the technology, a little far away from actually achieving it. We are actually writing the code, and some versions of it are running on our computers. But so what the guys who coined the term sidechains are doing is a little different. It's a more basic version that relies on merge mining. And what we do is a more advanced method to implement sidechains that, if it will work good enough, it will have very nice properties.
Okay, interesting. Meni, you are the only one here that is not working on a 2.0 protocol or technology, basically. You have Colu, Colored Coins, you have Ethereum, you have Zipper Labs. Do you think Bitcoin in itself can do the things that these guys are trying to provide? Is it enough? Do we really need these technologies right now?
Yeah, I think specifically with colored coins, which is the movement of using the Bitcoin blockchain itself to create all these assets and tokens, I think it has very high capabilities. I mean, it all depends really on Bitcoin scripting language. And I think we can get a lot of mileage with just that, just with Bitcoin as it is now. If that's not enough, then maybe we need to change Bitcoin, or maybe we need really to switch to something else. I mean, I think Ethereum is very ambitious in this regard. It wants to make the most significant changes to be the most flexible. Of course, if the project is too ambitious, usually the chances of success are lower. So we need to see how far we can get with just Bitcoin. Because, you know, in the past few years, I've been involved with Bitcoin for about 4 years, and about 3 of them, I started becoming interested in colored coins due to an actual need that I had. It wasn't just theoretical, although I do a lot of theoretical research about Bitcoin, its algorithms, how to improve the network, how to use it. But there was a time when the Bitcoin economy was booming, and people had all these small startups and projects they wanted to do. They wanted to raise funds for it. So back then we had a platform called Glebs, which was a centralized platform for issuing securities based on Bitcoin. But because it was still a centralized platform, it had all those problems. So we wanted to find a decentralized way to do it, and that's where people started to talk seriously about colored coins. The idea itself existed even earlier, but it was the actual need that caused people to start working on it. And that's I think this is best to understand if we think about what the Bitcoin technology actually innovates. What it allows, what the blockchain allows, is to create synchronization in a decentralized way. And the first application for this is currency, where you need all the players in the system to be in sync about who has which amount of money. But of course, this can be extended to all these tokens representing stocks and other financial instruments or smart physical property, and also proof of existence of information. So I think there is also, of course, a lot of connections between this and the applications that are used for the Internet of Things. Because here we also have all these devices connected in the Internet, and they want to be synchronized, and they prefer not to rely on some central servers, which could be clumsy and have all these barriers of entry. So really we have a lot of applications for these kind of things. And so back to your question, we can get a lot of mileage with Bitcoin as is. If needed, we can change it.
Okay, so can I expand let's take some particular example with Internet of Things. So let's say that you have some a display screen in some building, and this is like the thing that is connected to the internet, and you want to purchase some time to display your advertisement on this screen. So with Bitcoin, you can do that with a colored coin. So you pay with Bitcoins, in, let's say in an atomic transaction even, and you get some token, the colored coin that says that you can display your advertisement at particular hours. And this works well with colored coins. You can use, you control, you have the secret key, the private key that controls this token. So you can identify yourself to the screen and issue some instruction to the screen to display your advertisement. And now you have a Bitcoin, it's a public ledger, everybody can see the transactions and who owns which time periods that this screen displays advertisements. So this is great, this is a simple use case, but let's say that somebody turns off the screen or whatever, or moves it to another way, to another physical place or something like that, and let's say that you want a more complex script that the screen will send some geographical data of where it is, and you want to parse this data and only maybe get compensation for your original payment if the screen is not where it's supposed to be. So for that, you would need more complex scripts.
Why is that? Why doesn't Bitcoin provide that?
How will you parse data that says that this is the geographical...
You're saying basically Bitcoin doesn't allow that much metadata.
It doesn't have a scripting language that can parse some data that is some authenticated data that says that what was supposed to happen actually happened, and the script will be redeemed. You can get your compensation if this authentication happened or not. It cannot express a more complex script. So maybe Roman wants to discuss.
Mark.
No, I just wanted to comment that this is you're basically talking about smart contracts, and I'm not sure that it's not solvable on Bitcoin. There are the implementations of color coins now don't really deal with any metadata content at all. They don't decrypt it, they don't verify it. Basically, we can create a layer on top of Bitcoin that does that. I'm not sure if we're there yet, but this is another future problem we need to solve.
Okay. Can I ask you, one of the passions that I had about Bitcoin when I first found about it is the ability basically of computers to, computers, to basically do business with each other without human interaction, right? This is what one of the many dreams that Bitcoin offers to us. Like you described, the screen that simply somebody connected to the electricity and the internet, it stands on the street, and now people can buy advertisement space on it without anyone intervening. And if we go a little bit further, that screen can identify that it's broken, or someone can say, hey, listen, I'm not paying for advertisement because the screen is broken. So the screen will actually go and invite some kind of repairman to come and fix it. I would like to ask you about where your technologies are interacting with IoT, basically, where Do you have a vision for that? Do you have experiments? Do you have something that you're doing towards that? Apart from being a financial technology where you and I can exchange money, do financial transactions, do you have some kind of vision for Internet of Things, for autonomous devices? Roman?
Well, I think it's one of the aspects, really, of this revolution of Bitcoin. The idea of things, Internet of Things, right? So the things doing their business for themselves, right? Like you have this automobile driving itself, and charging the guy who called it, and then if it need to fix it, so it goes to the garage and pay for itself. If I want to speak about Ethereum, so Ethereum provide you as a developer with complete platform, with IDE, with a programming language, to develop algorithm for this machine. Like it's possible, and it makes it really simple. Unfortunately, we don't have the PowerPoint or some kind of screen I could show you, but you really have a you really have a programming language already, and you can program any kind of algorithm. So it would be, if I'm broken, go and pay for garage. Go and send the transaction to this address, which is the address of the garage, right?
Have you done experiments with this?
Yeah, we didn't connect it to the real taxi, but not yet. But I can make some simple examples like that. It's not a big deal already. Like it's very. If you're thinking about the real algorithm, the algorithm is really simple, right? It's not like they make. It's not so complex like to make the car really drive itself, right? It's much easier. So yeah, I think in Ethereum it's going to be easy because you also have we're also thinking about the endpoint developer that need to develop this kind of service.
What does Ethereum enable to the IoT industry? What is novel in Ethereum compared to Bitcoin, Colo? Is there something novel specifically about Ethereum?
Well, if you, I don't know if the guys in the audience remember, but Ethereum started as the idea that Bitcoin has this small part inside, which called the script, and you can put some kind of algorithm in this script. And it was really short, and you can do some specific, very, very limited something. And Ethereum came and say, hey, we want to put whatever algorithm you want to put. And it can be big and can be sophisticated. It can have if clause and while clause and for clause. And the classes and the polymorphism and object-oriented, whatever you want.
So basically, it's a complete cloud platform for, instead of relying on Amazon or AppFog or whatever it is, you're providing a full cloud platform, decentralized, uncontrollable.
Yeah, but the term cloud is already taken, so we are looking for something new. Like decentralized application is really the say here, because cloud is something that somebody controls, right? So Amazon has its cloud, so they control this cloud. We want to provide network that will not control. We really put it there. We provide the platform to develop, the IDE to develop the application on top of this platform. But we cannot control it. We cannot control the cloud to say, hey, you're allowed, you're not allowed to do this.
So basically, as a developer of something that does something on its own, I can use Ethereum completely on its own without using Bitcoin, without using C++, C#, whatever it is, or do use some kind of a programming language. Yeah. But you basically provide the entire infrastructure I need to connect my device to the internet, receive payment and send payments and do its job, basically.
Yeah, IBM did some demo a month ago with Ethereum when they taken a washing machine and the washing machine go and buys ingredients to make the wash.
Excellent. Tell us more about it.
It's all on YouTube, so you can find it. Just put IBM, Ethereum, IoT, whatever, you will find it. Yeah.
Okay.
It's called Adapt.
Adapt. Okay. Kolu?
Yeah.
Okay, Iddo?
Okay, so again about the Internet of Things. So as you said, Eli, so there are like two ways where you can use Bitcoin 2.0 technology to assist with Internet of Things. So one is that if you want to buy, let's say, or rent a car, and you want to do this secure payment where you get the token that allows you to ignite the car with your token to identify yourself, and this a secure way to transfer ownership by using the Bitcoin decentralized network. And so this is like the basic use case, and you don't need very complex smart contracts that are, so this can be done with Bitcoin itself.
Human to machine or human to human, basically.
Again?
Human to machine or human to human, yeah.
Okay, yes. It's a basic transfer of ownership. You can do like an atomic swap where you pay the Bitcoins, you get the token, and this is the token that controls the car. The other use case for Internet of Things with payment technology like Bitcoin is this idea of an autonomous washing machine, for example. So if something breaks in the washing machine, so the washing machine can recognize that something is wrong, and it has some wallet with some coins that inside, maybe you have a backup for those coins with some private key that you hold yourself, but the washing machine can operate autonomously and issue some repair instruction to call some technician to come and fix the machine. And this is again a use case where you don't need anything more complex than the scripting language that Bitcoin provides. So those are the major use cases that I'm familiar with for Internet of Things. And so I do agree with Meni that the scripting that is provided by Bitcoin is sufficient for most of what we can think of. In the case of colored coins, let's say, to issue a stock and pay dividends. So this is again something that can be done.
And with color, a washing machine can issue its own stock and pay dividends. This is okay.
So yeah, so no, but yeah, so about more complex smart contracts. So if you want something more complex than the Bitcoin scripting language as it is today, so there is this counterparty and master coin that add more features, and now you can try to think of some ways to authenticate yourself, like this idea with the geographical location that I mentioned earlier, that you can parse it and see that it's okay. And now if you want to do even something that is even more complex, that is queuing complete scripts that have loops and you don't know if the script terminates, and you have to put some gas into the script and all of that. And if you can find use cases for that cannot be done in other means, so that's more complex to come up with. But,
okay.
Just one thing to elaborate maybe a little bit, the adapt POC that IBM did with Samsung, it was a trial to do what they call appliance democracy, which is not really only technological solution to, but also a problem that IoT doesn't really have a proven business model. They try to think of something that can solve the problem of the business model for IoT. For instance, who is going to pay for the washing machine to connect to the internet and go to a very big cloud infrastructure and check every 5 seconds?
Well, if the washing machine is issuing its own stock, so all 5 of us, we can buy the washing machine and then...
No, so the solution was, what if all the appliances in my house would communicate with the TV, with P2P, with no cloud infrastructure, and everything will basically, it comes down to authenticating to a centralized server, but the server is a blockchain. It's a blockchain inside your house, or it's the Bitcoin blockchain. They're signaling us to stop.
Now it's a movie.
Ah, okay.
There's a movie for 30.
Okay. So that's so just to finish in sentence. There are 3 use cases, like 3, I think, groups of use cases we can use Bitcoin 2.0. In my opinion, there is the financial assets. You can create digital assets that are financial, like stocks, bonds, commodities, gold, your own currency. I don't know, if you want to create an economy on the blockchain, you can do it with Bitcoin 2.0. The second use case is information on the blockchain.
Identity, basically?
Public ledgers, public ledgers of information, medical records, anything, smart contracts, all the things that you can attach and verify and you can't forge, and it has an eternity on the blockchain. And the third use case is the basically ownership and authentication and access, and like Iddo said, with the car you can access the car, or the machine will authenticate itself to the TV, and the little sensor in my garage will find it's a shared layer of knowledge that anybody can connect to. Okay, I'm done.
Thank you very much. We have a question. We don't have time for questions. I'm sorry, Nili. Thank you very much for those who are attending. Thank you very much to the panelists. Good evening, everyone.